It's fine. It's all good. All right, we're going to do some integration today. We're going to integrate these various questions. I'm going to take a look at them. So the first one, we're going to integrate this just using our general concept of integration, the old fundamental theorem of calculus. So in order to do that, we're going to take x to the -2, and we're going to integrate that like we normally do. We're going to add 1 to the power and divide by the power. So what we end up with is add 1 to the power, -2 plus 1, x to the -1, divided by that power, -1. 10, 5. Stays the same because the reason it's 10 and 5 is we're finding the area under the curve between these 2 points there. So those 2 points are very important that they stay the same. Now, when we're actually going back and substituting in, we want to make sure we rewrite this right here in terms of a positive power. So the way we can end up doing that is if we take a look at this and know that, all right, well, anything divided by 1 is just itself. So instead of having x to the -1 over -1, it just ends up being -x to the -1. And then if we follow our negative index laws, it just becomes -1 over x. Remember that my negative sign can either be in the numerator, the denominator, or generally just out the front, as long as there is only one of them. So that's what we end up with, -1 over x, integrating between 10 and 5. And we simply just substitute them in and then subtract them. So it's going to be -1 over 10 minus -1 over 5. So we end up with -1 over 10 plus 1 over 5, and that's going to give me my answer, which is going to be 1 over 10. Just like that. Fantastic. Second one's going to work the same way, very similar way. So this one we're going between k and 0, and we're just integrating x. So we're going to look at what we've done before. We're going to add 1 to the power. This is x is to the power of 1 if there's nothing there, so it's x squared, divided by 2 between k and 0. Now, here we actually already have the answer, so it's good that we can see what we're working towards. So my watch goes off in the background, you love to hear it. So we're just going to substitute straight in here. K squared over 2 minus 0 squared over 2. Don't worry about it, doesn't matter. The watch, it's in the little cupboard there, it's fine. Oh no, I don't know how to turn it off. It's been going off like 4 years. So anything 0 divided by 2, still 0, so we just have k squared over 2, which is the same as a half times k squared. Remember that anytime I multiply a whole number by a fraction, it goes to the numerator, which gives us what we need. Now what we want to do is we want to find the positive value of k given that this thing we've just integrated is equal to 18. So we have a half k squared, and that's equal to 18. Now it's a positive value of k, so it's important to remember that when we are integrating, the larger number will always be on top. So we can't have a negative value because we've got 0 at the bottom. It's going to need to be positive. And we're going to do this, we're just going to solve this normally. We're going to times both sides by 2, we're going to solve this equation. Half times 2 is just 1. So we've got k squared, and we double 18, we get 36. What do? How do I get rid of the squared? Square root of both sides. So we have the square root of 36, which is 6, which is my value for k. Remember, technically it's plus or minus, so it'd be plus or minus 6, but because we want the positive value of k, that means our answer is just going to be 6. And then we have the final one. As of yet, we don't have a method to go like a reverse chain rule sort of thing. We don't quite have that yet. So what we're going to do is, because we have something that is squared, we're actually going to expand this. When we square something, we multiply itself. So we're going to essentially do that. We're going to expand it, and then we are going to integrate it. And because we can do each of the terms separately, it's going to end up working semi-well. So we have x times x, which is x squared. So I'm going to be integrating between 3 and 1, x squared. Then x times 1 over x is just 1 plus 1. 1 over x times x is just 1, because 1 over x times x gives you x over x, and anything divided by itself is 1. Plus 1 over x times 1 over x, which is 1 over x squared. All of that we're integrating with respect to x. Let's clean it up a little bit. So we have x squared plus 2 plus, and I'm going to convert this, just like I did before in the first question, into a negative indice. Because when we do a negative indice, it's going to make things easier for us to work with when we're adding by the power and dividing by the power. And it also helps us know, we know what it's going to go to straight away. We know, we've done it before, it's going to be negative x to the negative 1. Let's integrate, add 1 to the power, divide by the power. X squared becomes x cubed over 3 plus any whole number becomes essentially just the number itself with the variable after it. Because 2 is just like 2x to the 0. If we add 1 to the power, we get x to the 1, and we divide it by 1, we get what we already started with. It's just like differentiating, but the other way. And then we know what this one becomes. We did it above. It's negative x to the negative 1. All of that between 3 and 1. Let's write it out again. X cubed over 3 plus 2x minus 1 over x between 3 and 1. Substitute in 3 cubed over 3 plus 2 times 3 minus 1 over 3 minus, it's going to be 1 over 3 plus 2 minus 1. It gets very cramped in the corner. So, get your calculator out. We're going to have 3 cubed divided by 3 is 9. Plus 6 is 15 minus a third. Gives us 14 and 2/3. Minus a third plus 2 minus 1, which is minus 4/3. Subtract the two of them, and you end up with something I should be able to do in my head. You end up with 40 over 3, which is 13 and a third. So that's all it is. It's just making sure that you're setting it out in a way that you can integrate it or find the primitive of it using a method we've done before. And sometimes you're going to have to expand it, but making sure that you're substituting and then subtracting them from each other and watching out for a change in signs. That's integrating.